Let us conclude this class by seeing how the Levy method can be applied to identify models which are of fractional order. If the model is an implicit fractional order model, then we know that its frequency response is that of the integer order transfer function, which is inside parentheses, scaled up or down by a factor of alpha. Consequently, we can very easily apply the Levy method. All we have to do is to scale the frequency response that we want to identify by the inverse of alpha. So if alpha scales this frequency response down, we will scale our experimental response up. If alpha scales this up, we will scale our experimental frequency response down. Then we apply Levy's method and we obtain the integer order transfer function, which is here inside parentheses. All that is left is to raise it to power alpha. Of course, to do this, I have to know beforehand what is the value of alpha. This is the first thing that we have to know, just as we always have to know the orders of the denominator and of the numerator. The order alpha can be obtained, as we saw, from the slope of the gain and from the phase at high frequencies. The situation is more complicated if our fractional order transfer function is not implicit but explicit. Still, it is possible to use Levy's method just the same way. We will again minimize this quadratic error. And all we have to do now is to take care, because the powers of j omega will no longer be integer. We will have here powers which are fractional. Consequently, we will have more terms in our matrices A, B, C, D, and in our vectors E and G. It is a matter of carrying out the calculations again, now considering that we have these fractional powers here, and we will arrive at these expressions that let us apply Levy's method just as it was applied for integer order transfer functions. These expressions in the lecture notes are for explicit fractional order transfer functions that have a commensurability order. It is possible to apply Levy's method even if the explicit fractional order transfer function does not have a commensurability order, but calculations are far more complicated, and this case is not covered in the lecture notes.